Okay, good morning, all of you. Today we'll see continuation of previous one. How does machine learning works? So I have given a brief introduction about the machine learning in the last class. Now we'll see the how it is going to be work. In this black diagram, you can see here there is input data, and the data is giving training to that. Machine learning algorithm, and we have to build one algorithm. It depends on the type of machine learning. It may be supervised learning or unsupervised learning. In that, again, we have a classification, regression, clustering, then association. Many things will be there. And what it will do is learn from the historical data. So historical data, in the sense, here already available data, the past data, build the prediction models. Now here we are to build a model, that is a prediction model, and then it is receives a new data. Suppose we are training this historical data, and it will develop a one model, that is we can say that machine learning model. And then whenever if you ask something, new data, like if you have as a past data for climate condition or something like that, and once if you want to identify whether tomorrow rain will come or not. So in that, if we give the new data here, the automatically the model will give the output. That is a correct output it will give. Whenever it receives like that type of data, input data, and predicts the output, the particular inputs. Now here input is what, whenever you want to ask something, whether there is an interview process is going on based on his data. If you enter his features, let it be his 10th class marks, inter marks, then what is his credentials. If you enter all these things, automatically machine learning will give you whether he will select for the particular job or not. So like that, the model is going to return your result. Accuracy of the predicted output purely depends upon the amount of data. This already I mentioned yesterday itself. So if the input data is very less, so or some portion of some type of data is not trained by this model, then automatically what will happen? The output, whatever it is going to predict, that may not be accurate. So that's why what we need to do is, the accuracy of the model is purely depends upon the amount of data. So what is the input data will be there, that is amount of data. The huge amount of data is there means it will help a better model. That is only the thing here. Normally, if you say that Kaggle or something else hub, some data files be open, it is a lakhs of data also available. So the rows and all. In that, what we need to do is, for all kind of data is going to be trained by the model, so that it is easy for identify the new data comes, we can easily identify the correct solution. So that is the accuracy is purely depends upon the model. Now we can see that if the complex problems are there, some predictions. So instead of writing a code for it, what we'll do is we just need to feed the data to generic algorithms. So normally in the machine learning itself, we don't want to write any program. So what we need to do is we have to take it as a data. The data, whether it is a labeled data or unlabeled data, we have to train the model using the data, so that it is easy for them. And help of these algorithms, what we'll do is machine build the logic as per the data and predicts the output. So if we give the different kind of features, let assume that the interview process, maybe SSC marks A grade, and maybe +2 marks something B grade, then BTech marks or something else, and this different kind of propositions, then past data we require. if this is the grades or this is the credentials he's having, then whether he's selected or not in that past data, for that credentials, let it be he got placed, and other data credentials he may not be, and so on so forth. We'll get all type of credentials and we have the data. Now, if the new data comes into picture, if you enter the new data, automatically the model will give you the result directly whether he is going to be selected or not. So that kind of accuracy is there. If the input data is huge data, if you train, that is the thing. And now we can see some of the definitions as well. Learning is ability to improve one's behavior based on experience. Here the word is experience is very important. The model is going to be trained by experience as well. So that means learning is ability to improve one's behavior based on the experience. Then they automatically improve the experience if you build a computer system that automatically improve the experience. Fundamental laws that govern all the learning process are machine learning explores algorithm that can learn from data or build a model from the data. So the model, first of all, it has to learn from the data, then it build a model from the data. Use the model for prediction. So why this model? We are trained and then test if everything is fine, and then the model is ready for you for testing, and whenever new data comes to predict future data, we can easily use this type of model. A decision making or solving some task. So now if you simply feeding the input itself directly, it is going to be give the output because the model is already trained. The computer program is said to be learned from experience E, let us assume that, with respect to some class of task T, the performance measure is P. If it's performed at a task in a T as measured by P, then we can write it as improve with experience E. These are the terminology we'll use in the machine learning algorithm that Mitchell, that I already mentioned, is author for this machine learning textbook as well. And one definition you can see, machine learning is defined as the study of computer programs that learn, that leverage the algorithms and statistical models to learn through the inference and patterns without being explicitly programmed. This is the major thing we need to understand. Without being explicitly programmed means without writing any program, it is going to be learned. That's what the machine learning will do. So machine learning fields have undergoing significant developments in the last decades. So this thing is what we are finally mentioning is it is going to be learned without writing any program based on his experience, based on the past data, it is going to be experienced. Now we'll move on to types of learning. As I mentioned in the previously, the introduction itself, we have the different kind of learning mechanisms are there in machine learning. And first, in general, some of the books they specified only 3, but strictly speaking, we have 4 machine learning algorithms. One is supervised learning, another one is unsupervised learning, and semi-supervised learning algorithm, and reinforcement learning. So what is supervised learning? We'll go one by one in detail. As you already anyhow in the syllabus itself, we mentioned the supervised learning itself as one unit and unsupervised learning is another unit, and we will go in detail in that. But in the types of learning, I will explain briefly, or little bit in detail also. I will explain what is supervised learning and unsupervised learning and so on and so forth. And here, to classify or predict the objects, problems, or situations based on the labeled data. So here the thing is that data must be labeled. What is meaning of labeled is for the input this one, what is the output? Like that, we will very clear data will be available. Suppose let assume that 10th class marks is A grade, and then entry is A grade, and BTech is the some 90%, then output is is select, or let it be he will get the job, and yes or no. In that case, it will be yes. And other possible options is if 10th class is C grade, and then intermediate maybe something else, less percentage, or maybe B grade, and then BTech is 60 percentage, then he will not select. Like that, very clear cut data must be required in this, or you can say that labeled data, in the sense what is for this particular input, what is the output. Like addition, let you can consider. So A, B, and C is the data type. Let it be A is the input, and B is input, and C is the output. So we have to give the data 3 plus 2, 5. Then 3 plus 4, 7. So like that, we have to give huge data input. For this input, this is the output. That we call it as a labeled data. Output, if we specify, then we call it as a labeled. So that is the thing. The after this labeled data, this is going to be identified anyhow the problem situation based on the label data. And the supervised learning means the data must be as a label. And unsupervised learning to find the hidden patterns in the unlabeled data. So what it will give is, it will give only the input. We don't specify what is the output for this. Now we have to train themselves and identify what is the pattern. So let it be, I'm giving some set of basket. The basket may consisting of some fruits, the different kind of fruits, the different shape, different colors, and all kind of fruits will be available. Now we don't say this fruit is belongs to something apple, or this fruit is belongs to is a mango, or something else, or different colors you can say. So we don't say anything. What the unsupervised learning will do, based on that input, we have to identify the patterns, or we have to segregate this is one group, this type of size, this type of color, or this type of feature is belongs to one group, other kind of is another group. So next another color and similarities, based on the similarity will divide, this is the another group. Like that, it has to identify themselves, or hidden patterns. Based on the hidden pattern, we can easily identify that. So that is the unsupervised learning. And semi-supervised learning, so what it will do is here, in a semi-supervised learning,
Hello?
training data contains limited class labeled or
Hello?
desired outputs. So what it will do is, in this data, some data may have labeled data, some data may not be
Hello, sir.
having label. So this we call it as a what we call it as a semi-supervised learning. Means some data only having as a label. So that's why we call it as a semi-supervised learning. And reinforcement learning, this is a agents learns by the performing
Hello,
action.
sir.
Hello, hello.
Sir, are you? Is it audible now?
Yeah, you are audible. I'm
Yeah.
audible now.
Yeah, you are audible, sir. I have one question, sir.
Yeah, tell me.
Yeah, you said. Can you share your screen?
Yeah, already shared now.
That PPT presentation.
Yeah, it is already shared.
It is not available.
Others, what about Rahul and others? Hello.
No, sir, not visible.
Oh, but I
They're only
already
seeing
started.
participation.
Huh?
There I am seeing participation members, ma'am.
Okay, then I will share once again. But I already explained so far. Now I will share once again. Now you tell me. Now,
Is it visible, sir? Sir, here unsupervised learning means it is a predicted data, I can say.
everything we
Like
are
whether
going to predict only.
Like
Final task.
supervised learning is accurate value, I think so.
Everything accurate only are. The different is the input data. Suppose while you are training, input data must have the labeled data. Labeled data in the sense, suppose if you give the apple one image, you have to say this is an apple. Or if you give as a banana, you show the image as a banana, you have to give output as a banana. Like that, you have to train the model. That we call it as a supervised learning. But whereas here, in unsupervised learning, we don't have the output feature. We don't specify, simply data only available. Some different kinds of data is available. You have to segregate. This is a one pattern or clustering. Suppose class students are there. We are giving only the student marks. We are not specifying grades. So something marks is given, I have to segregate. So this group of members is related to this one group. I means based on their marks or based on their performance. Or other version also you can see some squares, rectangulars, triangulars. Like that, if you give the symbol, this model has to segregate this related to this type of squares. All squares will be in one side. Like that, it will be predict. All the things are going to predict only once if you give the new data. Anything?
That's also.
Yeah. So if anything is, I mean, the screen is not visible and my voice is not audible, if some kind of things are there, you call me.
Someone is
Because I
saying that your
already,
voice is low.
still it is low.
It is fine to me, but she is saying your voice is not getting to her. Maybe there is a internet connection with her problem.
Their problem maybe. My side is okay.
Yeah, yeah.
Okay, if any difficulty is there, you call me.
Sure.
Okay, fine. And now another one is a semi-supervised learning. Anyhow, all these things will have as one separate units in detail and with algorithms, how to solve the problems, different kind of problems. In-depth lectures will come the upcoming classes. It is all introduction. This unit itself as a introduction only. To briefly, but still one by one, I will cover in detail of the supervised, unsupervised, and semi-supervised reinforcement learning, all these things. But still, again, we'll come back in the second unit. It is exclusively for the supervised learning. Third unit is unsupervised learning. Like that, it will come. No issue. Now, that's what you can see. Semi-supervised learning is a training data contains the limited class level. Means now the based on the data, what will happen in this input data? We have some data. Suppose 1,000 rows are there, features in the data. It may be any number of features. In the data, some portion only will say the labeled data. Rest will not be having the output, clear cut output. Simply they will give the some patterns, some data. That we call it as a semi-supervised learning. And reinforcement learning, agents learn by the performing action and seeing the results. So this thing is very efficient, or you can say that what it will do is nobody is there to supervise, to train or something. This model as a robo or something else, it has to learn by themselves by doing some action. Suppose is in one place. If we move one step, you will get to know that whether it's going right direction or a wrong direction. If it is wrong direction, he have to correct himself and he go other direction. Like that, punish and punish. So something like that based on the performance, and you will get the feedback. Suppose if he did some good job, then he will get appreciation. If not, he will get punished. So like that, by his own, he has to train the model. So nobody will give the training here. Automatically, it has to train this model. That will be as a complicated normally the robots and all that will be trained themselves. Like this reinforcement learning will be the case. Now we can see and briefly what is meaning by seeing this supervised means the image tells you what is the supervised learning. So here you can see this is the student, let us assume that, and is a teacher. So what is learning will be with supervising by one supervisor. So there is a supervisor, under him he is going to learn something. So that is training mechanism here, because somebody will teach you or tell you something, this 2 plus 3 is equal to 5. So she will tell to this guy 2 plus 3 is equal to 5. So you can easily understand or you can learn things by supervisor. But whereas here unsupervised learning, nobody will, there is no teacher. He has to learn by himself. So based on the past experience, all these things. So that's why here is missing word is what? No teacher or no supervisor. And here nothing is there, reinforcement. He has to decide his action. So what to do? It is nothing but a artificial intelligence. So how, whether if we do something, you will get back the feedback. Is it is a correct or not, or what is this result of that particular action, and he will correct himself. Then again he will do something. Again he will take feedback. So this mechanism will be is a reinforcement learning. Now we'll go for supervised learning. Again, it is introduction only, but algorithms and I'll come back once again in the second unit. But what I'm going to explain in this, so what is supervised learning, what is advantage, disadvantage, what are the kind of classifications in a supervisor learning, and what is the difference of one to other. So all the brief about total about the supervised learning we'll see here. It is a type of machine learning, as I mentioned in the previous slide. There is a different types of supervised, machine learning algorithms are there. Like 4 algorithms are, one is supervised, unsupervised, semi-supervised, and then reinforcement. In that, it is a first one is a supervised learning. It is one type of a machine learning algorithm. Machines are trained using well labeled. This is the word is the different between with comparatively other kind of learning mechanism. Is well defined labeled training data. So in a training, I will show you that also later point of time at moment to try to understand what is the supervised learning. There is a well labeled training data. So the data, whatever you are using to train the model, the very clear cut defined label means what is the output for this input, what is the output, like that the data must have. So basis of that data, machines predict the output. So now once if your model is trained with the label, and if you give some more information as input, automatically it will predict the output. So label data means some input data is already tagged with the correct output. So for this input, this is the output, like that. Training data provides to the machine work as a supervisor. Now the data is nothing but a supervisor, because we have input, we have output, automatically we are giving as a very clear cut training to the machine. So that is the reason we can say it, we call it as a supervisor. That teaches the machines to predict the output correctly, because even if it is wrong, there is a supervisor is there, he will correct it, because the data is supervisory here. Input and output data is very clear cut. So it applies the same concept as student learns under the supervision of the teacher. So this is similar. That's the reason I shown you as image, the teacher and then student, or supervisor and then student. So that mechanism. Process of providing input data as well as the correct output data to the machine is a learning model. So this process we are giving is input and correct output also we are giving, then that we call it as a learning model. The aim of supervisor learning algorithm is to find a mapping function. So now what it will do is, in turn, suppose without saying anything, normally we'll give A and B and C. We don't know C is equal to A plus B. That we don't know. Simply model is don't know, but we are giving as a data, input data, A, B, C. Like that, I'm giving training. Then it is a 3. We are giving 2. Then let it be 2. It is a 4. And then similarly, suppose 3. Then 1. It is a 4. Then we can see 5. Then 7. Like that, simply we'll pass this information to the model. Then what it will do is, means the mechanism inside based on this data that learned from this experience, that will create automatically inside there is a program A plus B. Like that it will generate. Then if we pass, this is the, you trained like this. Then you are giving testing. What you are testing? 3 and then 7. If you pass, the input is 3 and 7 if you ask the output. Because these values is going to substitute here in turn, because it is already generated based on this input data. Then it will give C is equal to 10 directly. So this the way, once if we pass the input or later point of time, once the training and testing is over, then this is the input you are asking model to give the output 3 and 7 only you are passing, then automatically because the model is already trained these features, because of that it will give directly as output. How it is coming directly? Because the model is generated as a one algorithm, or you can say that mathematical equation based on the input data, and then we are giving as output. So this is the mechanism is going to happen inside. So input is X, let us assume that output is Y, and X versus Y, or let it be if we consider this is X and something this is a Y. If we give different features of X, X means it may have as a different X1, X2, X3 and so on also. Correspondingly, now you change the input model by training. If training data is changed, according to that training data, the output is going to be, equation is going to be in turn changed. Then if you pass the relevant data, then it will give as a output. So this is the mechanism is going to be happen inside. And in the real world, supervised learning can be used for the risk assessment and image classification, fraud detection, spam filtering. This type of application in the real world, supervised learning is going to be used. And how supervised learning will work? Now we can see that model are trained using a labeled data set where the model learns about the type of data, and once the training process is completed, model is tested. So here the thing is two things. One is we need to train the model using the labeled data, and also in the same labeled data, whatever you have, we have to test whether it is giving the result is correct or not. That is the reason whatever data is available, using the data, we need to segregate two parts. One is a training portion, another one is a testing portion. If these things are accurate, then only the model is ready. Now what is the process? You can see training process is completed. Then what we'll do? Model is tested on the basis of test data. So we have the training data and test data. The total data is dividing. Let it be somebody will divide 70% is training data and 30% is testing data, or else 80% and then 20%, like that depends. So we have to test. Then it predict the output. So once if it is completed two process, training process and testing process, then only it is going to predict the output. Working of supervised learning can be easily understood by the example. I will show you example also. Suppose we can see the data set different types of shapes. Let us assume that now the input is having different kind of shapes. Let me be square, circle, or rectangular, or triangular, or hexagon, whatever may be the shapes if we give, which includes the, let us assume that square, rectangular, triangular, polygon, something. Not only this, any more data also you can give. Now, first step is that we need to train the model. So how to train the model? We have to give some symbol, and you have to say the label is circle, suppose. And if you give the symbol is something like that, and you have to give the label is a triangular. So square, if you give, it will be as a 4 squares, and let you can give it is a square. So like that, we have to give the data. This is the first thing what I mentioned here. First step is that we need to train the model for each shape. We have to provide this is the shape square, give the symbol or image for the square, and tell to the model is it is a square. Like I mentioned in the previous slides last class, I'm giving apple and saying to the kid it is a apple, and then I'm showing mango, it is not a apple. Something there is a different kind of training we have to do it. Now we can see train the model for each shape. Then if the given shape is as 4 sides, then sides are equal, then we call it as a square. And 3 sides, then we call it as a triangle. So like that, we have to 6 equal sides, then we call it as a hexagon. And then after training, you have to test our model. So what is testing also? Some images you have to give to the model and then test. What we have to do for that model is to be identify the shape. If you pass the one model, because it is already trained with this training mechanism, and it has to say it is a square or it is a triangular or it is a circular, whatever you already trained. But if you not train the circle and if you pass the circle as a testing mechanism, then it will not work out. This is the major drawback of a supervised learning. Whatever you train to the model, that only it will remember and it will give you the result. If you not trained the circle images and saying that it is a circle, if you not done that, and for one new feature comes, if we pass the circle, the model cannot identify. That is the major drawback. Now we can see a simple block diagram. What is the happening inside whatever I explained so far. You can see labeled data. In a label data, what we asked is inputs. I given different kind of symbols. Square I given, then triangular I given, this hexagon I can given. Like that, if I give this is the input and model is going to train with these inputs, because this input consisting of symbol, and also we are giving like what I mentioned here, 4 sides are there and it is a square. Like that, we already given as a model for the input, proportionately what is the output. Then the model is trained. After training, what I have to do? There is some labels for testing. So now I am giving hexagon symbol and square symbol and triangular symbol. If we pass the testing mechanism, it has to say whether it is, if I pass this input, it is saying as a square, pass this, it is a triangular and hexagon. So like that, we are able to test this mechanism. So after testing, now if any new, if testing also correct, then what you have to pass? You are going to give the model some new prediction you want to do. Then what you have to do? This is labeling all be done. And if we give square some new data and then triangular. So if I give this way, it has to say output is a square and triangle. So like that, the model works like this. Labeled data, and then you have to train the model, then test the model. Then once that is happened, if any feature input is coming, if we pass the any of the image, the automatically it will give as a result. So testing case also, if we pass this, it has to predict for our internal. So after training and testing, if you any new object comes related to this, automatically model is going to say you whether it is a square or a triangular or a hexagon, something like that. This machine is already trained on all types of shapes. When it finds a new shape, it classifies shape based on the number of sides, predict the output. This is what how the supervised learning is going to be work. So this is very simple thing. And still some more things also we'll see. What are the steps? First is determine the type of training data set, then collect labeled training data, Then what we'll do, split the training data into two parts, one in the data sets, and then test data set and validation sets. Somebody will take only two broadly, training and then testing, and then determine the input features of the training data set should have the enough knowledge so that the model can accurately predict the output. So determine the suitable algorithm for model. So because how this is going to be happen, if you, I am saying is simply as a training, but what way we are giving training, there is algorithm. What is algorithm in machine learning algorithm? We have lot of algorithms. We have whether it is a what you call it as a different kind in the supervised learning algorithm, classification and regressions like that. We use that algorithm and we have to train the model, and model is going to be generated. And execute the algorithm on the training data set. Sometimes we need validation as well, control parameters, and subset of training data. These are all again in the data set only we are dividing. Evaluate the accuracy of the model by providing the test. So how to evaluate the accuracy of the model? If you test that model, if all the testing data, the results are correct, then we can say it is a more accurate. So based on that, if any deviation is there, we have to go for as a again training also you can do it to get data has to be in the later point of time it will come actually while we are doing normal projects and all. Whatever data we have to do pre-processing also, cleaning the data also is required, because if any mismatch is there or any data incomplete is there, if we train the model using the data, automatically there is ambiguity to find the result for the particular model. That's why pre-processing, cleaning, all anyhow that is normally out of this. So we'll do that mechanism before training the data. And now we can see some classifications of a supervised learning. What I'm explaining, types of machine learning is dividing into four: supervised, unsupervised, semi-supervised, reinforcement. Now we'll consider as a supervised learning. In a supervised learning, we are dividing as some classification. So what are the classification? We have linear regression, broadly classified regression and classification. In the otherwise, there is a different kinds. You can see that linear regression, broadly, if I say directly, supervised learning is divided into linear regression, logistic regression, k nearest neighbor, support vector machine, decision tree, random forest. So these are the some of the classifications or types of a supervised learning. So, or you can say in the broadly, in general, this will comes under regression and all. So some will comes under classification. So like that. So, but we'll see this too is a broad classification. One is a regression, another one is a classification. So regression algorithms are used if the relationship between the input and variables and the output variable. So this is a regression, and it is used to prediction of continuous variables such as weather forecasting and market trends. So this is one word you must remember: continuous variable. So regression will give as a continuous variable, whereas the other classification will give as a discrete. So that way also you can say, but at moment you can see that regression will give continuous variable. And a regression algorithm which comes under the supervised only, linear regression. Now we can see that some classification will comes under regression. So here in the regression, we have linear regression and regression trees and non-linear regression, Bayesian linear regression, polynomial regression. So these are the different types of regressions. So anyhow, this individual of again one by one will comes under second unit, that is a supervised machine learning algorithm. So these are the different kind of regressions we'll be having in the regression. We have linear regression, regression tree, non-linear regression, Bayesian and linear regression, polynomial. And similarly, we'll go for classification. In classification used when the output variables are categorical. So this is a very, what you call it as a whether yes or no or true or false or male or female, it is very categorically. It will not be as a continuous. So this will be as a algorithm used when output variables are categorically, which means there is a two classes only. This is fixed, either yes or no, or true or false, or something very clear cut picture. For that, like a spam, and the mail comes, whether it is a spam mail or genuine mail. So like that, or the customer comes is a fraud customer or a genuine customer, something like that. So very filtering, random forest, decision tree, logic regression, support vector. So here support vector machine can works for classification as well as the regression as well. So these are the some of the algorithms are available in a classification as well. Now it is a trained using label data example input where the desired output is prior known, means we must know that. And for example, piece of equipment could have the data point whether it will run or not run, or failed or runs. So any while you are testing that. So algorithm accept the set of input along with the corresponding true results, and then algorithm learn by comparing its actual results, correct the results to find the error. So then it will update and modify. Suppose if there is error, then again it will learn, then it will update his model. Like that, methods like classification and regression, gradient boosting are used to predict the value. So because in a supervised learning, again I mentioned in the previous slide as well, classification regression. Again, classification is divided into different linear classification, something like that. And regression, we have different kind, but using these methods, we are going to be trained. Supervised learning is usually used to environment where the historical data predicts the future proceedings. So historical data, that means past data, we need to learn this. For example, predict credit card transactions. What we have to do, whether it is a fake transaction or which insurance customer is likely to fill a claim or not. So based on the this data, we can easily understand. I mean, for this is an example for that actually. What we need to do is using the supervised learning, we can easily identify credit card transaction. Once transaction is done, bank should know whether it is a fake transaction or a genuine transaction, like that. Our insurance customer also, whether he will file a claim or not based on his past data, his health data, or like that. We have many, it is all about related to data. Now we can see this is another black diagram, different kind of black diagrams also there. I already shown you one black diagram, how the machine learning in that supervised learning will works. We can see that machine learning algorithm, the model is going to be trained using the available data. It may be anything, training a text, a document, or image, or sound, or anything based on the feature vectors, and it will train. And we have to give the label also for that. That's the reason of supervised learning. Will give labeled data only. And once the model is trained using this test, once the new document comes, we trained with this text document so and so, this is the label, and image is so and so, this is the label for that, and different kind of sound, this sound is related to this bird sound or something like that. If we train the model, now once if you new data is giving, now the new data means after 1 year something is comes, the data have to pass, then automatically it has to give the output. So this is comes related to output is this is the label. Whether it is a new text document or image or a sound, then if we pass to the model, the predictive model, it is going to give the output. So now we are training this, the machine learning through the algorithm, then this is going to be model is going to be developed. That is, we call it as a predictive model or a machine learning model. After training and testing, this is ready to predict the label. So now if we pass the any input, then automatically it will give as an output. So this is the thing. We can see that use case, you can see that to build the models, use the predictive data analytics applications. We use the supervised machine learning algorithms. For predictive analytics, we can use that. This algorithm techniques automatically learn a model of the relationship between the input and output, or you can say that features and target. So what are the features? Are inputs. Let it be A, B, C are the inputs. Output may be anything y is equal to a plus 2x plus b plus something, whatever the one equation, that is the output. So now this the features and target based on that historical examples are instance we required to train a supervised model. You can use this model to make predictions of a new instances. And this is also one example you can see here. What I'm doing is I had to develop a predictive model. You can see this model I had to develop. What basis I had to develop? Training data set. There is a lot of data will be available. In the data, descriptive features. The one feature is this second feature, third feature, and so on. These are all the input. Corresponding input, what is the targeted feature? So what is the descriptive feature means inputs, and this is a output are also called as a target. So you remember the terminology in a machine learning output, we call it as a target. So now we have to give the features is the inputs. For these features, what is the output? So for that input and output, we are giving training to the model. So this data is given to the algorithm will train this model, and it will generate in turn as a one relevant appropriate equation or a feature has to develop. That is nothing but a model. So once model is ready, then what you have to do is a query instance. So you are passing one query. So by using some other